In this video, I will show you how to do the analysis in Excel for question number 5 on the mastery assessment. So they ask us here, perform an independent samples t-test for the variable total cholesterol, for BMI, and for systolic blood pressure between females and males. Now you will be doing between without chronic heart disease and with chronic heart disease. So I'm going to be paying attention to column A. You're going to be paying attention to column E when you do your analysis. So to do a t-test, you want to go to the Data tab, then click on Data Analysis, and scroll down if you need to, and you want to click on t-test to sample assuming equal variances, and then click OK. Now, there shouldn't be any data filled in for the ranges in your dialog box here. So it should look like that. So you first need to select variable 1 range. That is going to be total cholesterol variable values for, in this case, for females. So I'm going to click on that first cell that's got a total cholesterol, first 0 cell, total cholesterol value. Then I want to scroll down to the females ended at 2365, I believe, which is at 600 right there. I'm going to hold the Shift key and then click on the 600, B2 to B2365. So you're going to be doing the same thing again, except you're watching zeros and ones in the last column instead of the first. Click on variable 2, and this is the males for the example. So we are going to start our males at 2366. So that's going to be the total cholesterol for the first value that has a 1, which in this case is the 113. We're going to scroll down to the end of the data and grab that last cholesterol value, holding the Shift key, click on that 439. Our hypothesized mean difference, you want to enter 0, because we just want to see if they're equal or not equal. Alpha should be set at 0.05, and then you want to click on output range here. And for your output range in here, you want to scroll all the way back up to the top and then just select a convenient cell. So maybe this cell right here. And that's going to be the upper left-hand corner of your output. Then click OK. So our variable 1 here, that was female, and variable 2 was male. And what we see here is mean for females is higher than the mean for males. Total cholesterol was higher. The variance for females and the variance for males had a little bit more variance in the female sample. And then the important value here is this one right here, P two-tailed, right there. So your p-value is 3.8 times 10 to the -6 value. So that e -6, again, what that means is it means 3.8 times 10 to the -6 power. That's what that e means. And that's how you'll report it. And what we see is that that p-value is less than 0.05. So that means that we are going to reject the null hypothesis, H0. So the null hypothesis is going to state that the cholesterol means are equal. Okay, but ours are not, because our p-value is less than 0.05, which was our significance level. So on the basis of this sample data, we will conclude that there is a statistically significant difference between the cholesterol values of females and males. So next they want us to do the same thing with BMI and systolic blood pressure. So let's just scroll down here just a little bit. We'll place our next table right here. So we're going to go to the Data tab and Data Analysis. And we're going to click on two sample test with equal variances again. And it brought up our data from previous selection, which was column B. Well, now we are looking at not total cholesterol, but systolic blood pressure and BMI. So let's do systolic blood pressure next, which is column C. So all you have to do is click in here and change those B's to column C. So that is a C, C2, and then change that B to a C, and then do the same down here. Change the B to a C, and then I messed that up. I'm going to cancel out. Click OK again. Yeah. Okay, so we'll change a B to a C. Click over here. B to a C down here. So it's the same cell range, but it's in column C instead of column B. So all the B's I replaced with C's. I will click for my output here. I'm going to output it down here so it doesn't go over the last table. So I'll erase that and then click it's G22 and click OK. So now we can interpret this. This is for, again, for females and versus male. And this was BMI. So I might, I'm sorry, this was systolic blood pressure. SYS, BP. Let's go up here and insert our variable. This one was total cholesterol. So when we go back, we can tell which variable. And here we can see that the BMIs are, I'm sorry, systolic blood pressure is pretty close, slightly higher in the female than in the male, and more variance in the female, more variation in female values than male. The important value, again, we're testing equal versus not equal, is right down here. That's that p-value, 0.017. And what we see is that 0.017 is less than 0.05. So this is a statistically significant difference. We're going to reject H0, reject the null hypothesis that the two systolic blood pressure values are equal, and we're going to conclude that since the p-value is less than 0.05, that this difference is statistically significant. Now, notice that this one really doesn't have a practical significance because they actually differ by less than 2 points. So blood pressure systolic of 133 versus 131. Well, your blood pressure can vary that much from, just standing up to sitting down. So not a practical significance, but we do have a statistical significance. And then let's do the last one, which is BMI. Let's place that table down here. So again, we're going to go to Data, Data Analysis, click OK for our two-sample t-test. We want to change those C's to D's to do BMI. So I click in there, change the C to D, and click here, change the C to D. Don't use the arrow keys to arrow around inside that box. It'll mess up the formulas. So delete that C, change to D, and then last one, change to D. We want to change our output range to cell G38 and press OK. So this was BMI. And what we are seeing here, if we scroll down, is that BMI was, this was female and male. So BMI was lower in females than it was in males. Is that difference statistically significant? Well, we go down to our p-value two-tailed here. And again, it's in scientific notation. This is 1.23 times 10 to the negative 7. So that means move the decimal place 7 points to the left. So that's really 0.000000123. That is certainly less than 0.05. So again, we reject the null hypothesis. So we conclude that this difference is statistically significant based on our sample data. Now, practical significance, this is only a difference of about half a point, approximately. So that may, again, not have a practical significance.